Good morning. Thank you for waking up. It was probably an effort, right? I came from East Coast, so Sunday morning I woke up at like 4. Monday morning I woke up at like 5. This morning the alarm went off at 6. That was the first time I needed the alarm. It's going to get worse as the week goes on. But thank you for coming. I hope you have a coffee or whatever else you need to bring your brain into gear, because I want to talk to you about nothing. When you write code, who do you write that code for? Like, the compiler has an opinion, right? It's going to object if you get your syntax wrong. But the compiler does not care what your variable names are. They could be A, B, C, A1, A2, A3. Compiler wouldn't care, but the people, yourself, while you're thinking it through. So the total revenue is the European revenue plus the North American revenue. And calling them that helps you. And of course, you partly do that because you know you'll be back in this code again. And always, we are appealing to your altruism when we tell you to remember that other people are going to read your code later too. And I've noticed a switch in the last few years from pretend your code's going to be maintained by a violent psychopath who knows where you live. That was a real popular saying. Now we have a more tender and generous approach. Pretend your code is going to be maintained by your own child. And I think that will make you write very, very good code. But you see, the reason that it matters is because writing code is communicating. The communication with a compiler is short and brisk, and a lot of it doesn't matter, like your variable names, but you're communicating with the future. You are talking to future you and future coworkers and future people you have never met and never will. And you're leaving these kind of trail markers behind. This is a picture of some trail markers. And the obvious thing, the yellow and brown thing in the foreground, for those of you who don't take a canoe into the wilderness and carry it between lakes, this is a place where a hiking trail and a portage trail coincided for a little while, and then the portage trail breaks off. And so the bottom symbol, the person with a canoe on their head, is the universal portage symbol. That's not what I want you to look at, though. If you look on the trees in the background, there's a blue circle on one tree and a yellow diamond with something on it that you can't quite make out, which is actually, again, the portage symbol, Mr. Canoehead. To absolutely emphasize, this is the way to go. Go straight if you have a canoe on your head, and turn left if you're just walking. And so not one sign, but 2 signs, because it's kind of important. That's like a 50-kilometer hiking trail. And if you have a canoe on your head, you do not want to accidentally walk 50 kilometers. Well, that's what you're doing in your code. Like, it's not enough to say, well, this code compiles, so I must be a winner. Please give me my salary. It's not even enough that your code runs, although like it has to. I started out in math. It's necessary but not sufficient for your code to run. Your code has to be understandable by your fellow humans, which means we spend a lot of time reading code. And when I read code, I come into companies sometimes to help them, or I pick up a project after 10 years, and I ask myself these sorts of questions. What the heck does this do? Why is it doing that? Has anyone proven this is right? Like, does this work? Come on, you're telling me this actually does? Who wrote this garbage? Oh, me. Like, why did that complete newbie, that absolute beginner that was me 2 years ago, never think about blah, blah, blah? And so, well-written code pre-answers those questions. Yes, it works. Yes, it's cross whatever it needs to be for your universe, but it has the answers to those questions in it. And not like this. And technically, that tells me who wrote it and when, but if I never see another comment like that again, it'll be too soon. The way you answer those questions is because the code expresses itself. It is open and obvious about what it does, how it does it, why it does it. When you read it, you understand it. It communicates. Now, I spend a lot of time talking about this in general, and I want to zero in on one little part of it today. How many of you have met or heard of Roger Orr's favorite code snippet? I get like 1 or 2 hands. It's a shame. It's a marvelous code snippet. There was a thing, I think the ACCU did. They're like, what's your favorite 10-line or less code snippet of C++? You can think of someone in your head. This is what he suggested. Right? Come on. That's amazing. Right? Think what happens when that happens. That's amazing. And that's a very, very dense code snippet. Right? Depending on how many things you have in scope, when you hit that close brace and all their destructors are going off, all the stuff that's happening. So in terms of stuff divided by characters, that's very intense. But I can beat it with this. I don't have another build. That's the symbol. I want you to think about what this token, that is to say, no token whatsoever, means in your code. It's one thing to choose a good variable name, total revenue, instead of B, but how can you make nothingness communicative? That's what I'm asking you to have another sip of coffee and think about. Here's a boring class. Oops, I broke my own punchline. Here's a boring class. It holds an integer, right? It's got a constructor, it's got another constructor, it's got business logic that increments the number, it's got a get number, and it's got a toString. If you've ever done any kind of intro to C++, you've seen something like this or someone's written it for you. And here's a different version. And when I see the different version, I go like, oh, so before, the one argument constructor was not marked explicit. So it could be implicit. So you could make a holder, right? Say holder h equals 7. Now you can't. Oh, get number's marked const and so's toString. That makes sense. Get number, the implementation's right there. You can see it doesn't change a member variable, right? I don't see the implementation of toString, but if it changes the number, I'd probably be pretty angry. Again, that's about communicating to humans. The compiler's like, if you want to call it toString and then increment number every time it's called, compiler doesn't care. And toString is virtual, and back here it was not virtual. So it's not just that these two classes are really different. It's that on this slide, you probably didn't think, and I know I told you it was trivial, kind of turned off your thinking. You didn't think to yourself, I wonder if any of those functions are const. But as soon as 2 functions are marked const, then you notice that inc is not, which makes sense because it increments the number, so of course it's not const. But now the nothing is sort of standing out. Now, we have lots of pairs of opposites, right? Plus and minus, dereference and address of, all the brackets. But most of C++ does not have opposites. And what is the opposite of return? It's whatever line of code you want to have next, right? What's the opposite of calling a function? I don't know, not calling that function, calling a different function? Like there's no answer. And I want to specifically talk about things that could have opposites, but don't. So virtual. The opposite of virtual is nothing. The opposite of explicit, nothing. Opposite of const, nothing. I have a theme. Even taking a parameter by value, you don't put any punctuation when you declare that function. When you take it by reference or by R-value reference or whatever, now you start loading in punctuation. And so I got kind of interested in this, in things that are the opposite of nothing, because we want to be able to make our code express itself, but we don't seem to have any raw materials for that expression. And I want specifically to talk about 3 new C++ 17 attributes that don't change the way your code behaves at all, make no runtime difference whatsoever, but they affect your compiler and the warnings that it issues. So here's a switch. We're switching on some variable I, and in the case of both 1 and 2, we're going to do the same thing. That's common as dirt. We all do that all the time. And then we've got 3 and 4 and a default. And I've kind of telegraphed it because of the wording of the message for case 3. Normally, you don't see that hint of the or hanging out there, right? If I is 3, this is going to do both case 3 and case 4. It's going to fall through into case 4. And the fall through from 1 to 2 is common and ordinary and normal, and there's nothing weird about it at all. But the fall through from 3 to 4, it's not common. It's probably not even normal. And it could be a mistake, because you have to remember to type break at the end of each of your cases. And if you quickly go in and stick one in, you might be like, oh, and then in case 3, I'm going to, and then you leave, and then you forgot the break, and now you're falling through and doing the case 4 stuff. I often see it right before a default, right? Because we've added another value to the enum, and we've come in and added another case to the switch statement. And some compilers will warn you if you fall through like this. You can put a comment. The compiler does not read comments. And I do not want to open the door to the compiler reading comments and backing off of warnings because you had a comment. Bjarne likes to say the compiler doesn't read comments, and neither do I. And I think it's a pretty good point. This comment won't make a compiler happy. It just causes a human to maybe ignore the warning. I'm very anti-ignoring warnings, okay? A warning that can be ignored is not doing its job. So this is a C++17 attribute that the compiler reads. And unlike the comment, if you use the attribute and then break, you'll get yelled at, okay? So it will stay consistent, which the comment does not have to. So in terms of the way your program runs, there's no difference whether you have this attribute there or not. It's not that the opposite of this is nothing. This is actually the same as nothing. But it's not, right? Because A, it's suppressing a compiler warning, and B, it's speaking to humans. And those are both really good things to do. Let's try this one. I have some function that does something, reads a file, writes a file, whatever. I need to call this function, and it returns a value that is kind of sometimes occasionally important. It's more important than the return from printf, but it's not really important once you know the program is working. So you have some assert involving this return value. And I can't say assert function with side effects is greater than 0, because then when the assert falls away in a release build, I won't call the function, right? But when the assert falls away in the release build, do you know what I get? I get an unused variable warning, right? Because I put some value in this j, and then I did nothing with it, and I'm obviously a bad person. And again, if you treat warnings as errors, it's now not possible to get a clean build. And people do all this gross things with testing for debug and stuff like that. But this attribute says to the compiler, I get it. It's possible I'm not using this variable. Leave me alone. And you won't get the warning. That's also handy for a variable that you only have there for when you're in the debugger and you want to see its value, but no one ever does a calculation with its value. You can also use it for that. So again, there's no difference at runtime between the top line on this slide without the attribute and the bottom line that you see right now without the attribute. It's simply a matter of suppressing the warning in release when this assert line falls away. But it's doing something. Not just changing the compiler, but it's also doing something to the people who read the code in a way that a comment does not. Another kind of nothing is when you don't use your return value. So I have this function getNumber. It took me forever to code this. I have slaved over the demos for you people, I want you to know. Fine, I can put the result in this local variable, but I don't have to. Now, this is a really stupid thing to do because there's no side effects in that function, so it's a pointless behavior. But if you haven't met any code yet that does pointless things, then you have not been in the industry long enough. So if the person who wrote getNumber feels that this would be a very important mistake to avoid, they can put this noDiscard attribute. And now, everything's still fine if I put it in a variable. If I don't put it in a variable, I will get a compiler error, I believe, but it might be a warning, discarding your return value when you said no. So this is a different kind of nothing, right? The nothing of not bothering to use what you were given. But now as the author, the giver, I can say, you will not ignore what I give you. Now, you might put it in a variable and mark that variable as maybe unused. I can't stop you, but something is going to happen with the return value. I am not printf. I need you to at least look at my return value. So this is something that didn't come up when I was first programming in C++. Because the teams I was on in the 80s were teams of 1. And I didn't think my code would last long, Y2K problem. I didn't worry about communicating with my teammates because I didn't have any, and I didn't worry about communicating with the future because I didn't really think the application had a future. But today we have teammates, and today we have the future. And so we are communicating with them, and we are finding things that are semantically perhaps the same as nothing, except that they communicate with the future. And that's what I really want you to think about, expressing intent in a place where you don't have to. Last night, the quote was, by default, all the defaults are wrong, and that's the wrong default. Is that what Titus said? Something like that. And it's become a trope that all our defaults are wrong. And I'm not going to argue, should things be mutable by default and only const if you mark them? That's pretty supportable. Don't use defaults if you have a choice. So when I go class, employee, open brace, the next thing I type is private colon. You know I don't need to do that, right? You know in a class they're private until you say otherwise. I do it anyway. I do it partly because not everybody knows that, and partly to just be super clear. It doesn't take long for you to go look that piece of information up. We're all very good at looking up things in our own brains or on CPP reference, which is close enough. But it does take a little bit of time. It's kind of like getting stuff from cache. And so when I put private colon, you don't have to do that. And yes, I will do a struct point with an int x and an int y, and it will say public before them, even though, of course, they already are. I don't fall out the bottom of void functions. I have an example on that later. Once something's virtual in the base class, you don't need to say virtual ever again, and you certainly don't need to say override, but you can, and I'm here to say that you should. Many people say that you should because if you are an idiot, like me, and try to override something that isn't virtual in the base class, you'll get an error message. And while they're not wrong, that's an easily rebutted argument. You simply say, like we all say all the time, oh, great rule, but I'm not an idiot. Well, okay. Yeah, I often am, but that's not the reason I'm giving you that rule. The rule is so that the person who reads the derived class doesn't have to go up and look. You're telling them it's an override. And you can't say override if it's not, so they don't have to check. The compiler has already checked. They can count on it because it's a keyword, not a comment. Got any no except fans? I think people are just tired. Like I got like no hands, and then slowly I got, oh, wait, yeah, actually I know what that is. I've heard of no except. That we have no except at bool so that people can do like complicated Sphene things, blah, blah, blah. But you can just say no except false. That's legit. And it means exactly the same as not saying anything to the compiler. But of course, to me, it says this function probably throws, could throw. I've thought about it. I've heard of no except, and I've decided it doesn't apply here. And that's huge. That's a big, big piece of information compared to not saying anything. Think about how long it takes you to make a decision about what to do in your code. Sometimes it comes out of your fingers as fast as you can type. But other times you're going to stop and like go and talk to someone and do things at a whiteboard and finally come back and put one character into the file. Or don't type something, right? Oh, this constructor shouldn't be explicit. And then what do you put in the file? Nothing. But you just spent like an hour to make that decision. Why isn't it there? Why does everyone else have to re-guess that decision every time they read your code? So you're trying to save that time for other people. Now, we do not have implicit, right? Would you use implicit? Now, I'm happy, because now I think this hand delay was like, I never thought about that before, but yeah, maybe I would, right? Because sometimes that's what you want. You actually want people to say holder H equals 3, and you don't want someone else coming along who's read 1.5 textbooks and has heard that constructors and conversion operators should be explicit and slams explicit on everything without thinking and breaks your code. We can't say not const. Mutable and const are not really opposites, right? But it might be interesting. We don't have non-virtual when we declare a function. And this is not VB. We don't have by val when we're declaring parameters or passing parameters. But you can kind of see how maybe some days you might want them. Please don't do this. I've seen this kind of comment. The famous one, of course, is trust me on this magic. That person can live in legend. The rest of us do not get to do that. This is a little better, right? Drawing someone's attention to your nothing, passing it by value, but you haven't said why. You haven't really communicated as much as you could. I mentioned this before, but I really want to spend some time on this. If you have a function f in some class x, and I'm choosing these names deliberately because to show you know nothing. It's not get last name in employee. You know things about that. You don't know anything. And it doesn't say const on the end. Your decision now is, might that really truly change member variables or not? And you need to know this for some reason that I'm not going to, stuff happens. And you have to shake the screen and try to reach that person who in 1991 wrote this code and say, did you just not know there was const? I'm not sure if there was in 1991. I have a 25-year-old and he's younger than mutable, okay? But you've heard of const and you just didn't consider it here. You didn't think it mattered. You only use it when it matters. Or you've heard of const, you use it all the time. You're a real pro-const person. My badge is off. You're an East const person because that's correct. And you're just not using it here because you can't, because it changes. If I look at the rest of the code and I see lots of const, then when I bump into the function f in class x and it's not marked const, I can immediately say, this function changes member variables. If the parameter is not a const ref, but just a ref, I'm like, oh, it's an in-out, they're changing it, right? I've learned from the rest of your code base what nothing means right here. So that's kind of weird, because you're on a team now that's spread across people, but also across time. And you know about const, and the whole rest of your code base doesn't say const anywhere in it, and you don't want to use const here. Does that mean you now don't need to go fix the whole rest of the code base in order to cause this absence of const to speak loudly? I try to save the comments for the surprising or tricky parts of the code. And I will say, I know this looks like X, but it's really Y. So if you have, for example, a get temperature, that name tells us all it should be const. What did I have before? ToString shouldn't increment number, right? So if you have a name that makes people think it's just a simple get, but it's like, oh, actually, I get the temperature from the sensor, and then I cache it, and I change the date last temperature was got or whatever. So it's not const at all, and that's why. And you put a comment and you explain why you're deceiving people. I mentioned falling out the bottom of a void function. Take a look at this one. I got fed up of having F and G, so I made nonsense words. They're also easier for me to tell apart when I'm talking. So I have this function thimbule that takes a robot and messes around with it, might return in the middle, but falls out the bottom. And there's no return statement there. Other void functions do not fall out the bottom. This is Sprile. It takes an oob and a boo, messes around with them for a while inside a while true, and if oob finally manages to get bigger than boo, we'll return. And until that day, we will not. There is no falling out the bottom. And that's an important piece of information about Sprile. And never having return on the bottom of thimbule, you're hiding in nothingness the important information about Sprile. Okay? If you always have a return at the bottom, if you can actually fall out the bottom, then when there is no return before the last close brace, it's because this function doesn't fall out the bottom, which is something people might need to know. So you're actually adding information to the spiral function by typing more code in the thimbule function. And that's I'm asking you to do something quite strange, right? But that's what I'm asking, to make your nothing mean something. There has to be something in the equivalent places elsewhere. All the cool kids do ranged force all the time, right? It's a pretty good one. I'm gonna go through all the employees in the department. I'm gonna do something with them. It's boring until I show you this one. When I show you this one, most of you reevaluate the first one. Oh, I guess maybe employees are expensive to copy or non-copyable or something. So that makes sense. We're going to go through references. Okay, that makes sense. That's cool. I get it. And then I'll show you this one. And now you reevaluate your opinion of the middle one. Oh, the middle one must be changing the employee, right? Because you're not taking a const ref. And these aren't necessarily valid conclusions. EMP did not become more expensive to copy because I put an ampersand in my code. EMP is or is not expensive to copy. Did I naively work with a copy, work by value in the first example? Maybe. The middle for loop, if it didn't have ... wouldn't magically start mutating these employees because I didn't say const ref. It does or it doesn't mutate them. But now you start to think about the possibility once you're reminded that if it didn't, it could say it didn't. So again, you have this cool kids effect. Someone who's just starting in the language, they go auto-emp : department because that's what they were taught. And they do it no matter how big the thing is, and they don't worry about perf because we have big, powerful computers and it's not an important loop and blah, blah, blah. And then someone else tells them, you should be doing that by reference. And they may even be right in that case, but the learner says ranged for loops should be by reference, got it. So now all their loops are by reference, whether they need it or not. And then another cool kid comes along and tells them, but you're not changing anything, so it should be const reference. And very often they hear, oh, all the ranged fors should be const reference. And so you don't know if these artifacts are in the code on purpose or not. And yet, they send us information. When I don't see that, the first one, I don't see any punctuation, it sends me the information, this guy's cheap to copy, or this loop is a very small loop in a tiny backwater of the program. It would be wonderful if those things were true. I want you to write code where you only send those messages when those messages are true. That's really that's my message today, right? Think about what you send. If it's not true, don't say it. So in the middle one, if it's not true that you're going to change it, why are you saying that you might? Put the constant. So this requires a little more like meta thinking. Your head's already full of, I need to go through all the employees in the department and blah, 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 blah. And then on top of that, you need to be saying, not just what about performance, but like what message am I sending to the future? And I understand I'm layering work on, but for me, when I come in 15 years later and nobody knows what the heck it's doing or why it works, I'm desperate for this kind of context and this kind of information. And it's true when you're passing parameters exactly the same. Let's create an order. We take a customer and an order item. Do we? Would that be right? Like, wouldn't a customer object somehow be able to get to its orders? So wouldn't the act of creating an order somehow change the customer by adding something to its collection? So if I see that you take a customer reference, I'm like, that makes sense. I know what you're going to do to the customer. It's non-const reference. I learned something. You're still taking the order item by value. Why are you doing that? Why is it going to have an independent life outside the order? What, is it going to go in another order as well? Like, why is this a copy? Well, if you go to enough conferences, you start to meet the people who are like, take it by value and then move it, that kind of thing. So you're like, oh, maybe that's what's happening. Maybe it doesn't have an independent life outside. You're going to move it inside, which has some performance benefits if that's an R value. Now we're back to const ref on the customer, and I'm like, what? The customer doesn't know about its orders? So most of these signatures are confusing me a lot. And you're focused on perf, maybe const correctness if I'm lucky, but I'm saying like, what are you telling me? And it might not hurt to throw in a comment, okay? Perhaps this thing returns an order. Perhaps whatever created the order will now also go and tell the customer this is your new order. And it is in fact the case that the create order function doesn't touch the customer at all. It just uses it for pricing tiers or something. That's cool. A comment here would help with that, right? So you think it's just all about, well, how expensive is it to copy a thing? There's more going on than that in terms of people understanding your API's philosophy from just looking at a couple of signatures. The middle one is the one that I'm most likely to think the person thought it through. Both the top and the bottom one, I think, are kind of just reflexive habits and hasn't had a lot of thought put into it. And that's just, I'm going to say probably just prejudice on my part. There's probably, I don't know if there's anything technical behind it. I'm just telling you how it makes me feel. Probably makes you feel something similar. Another kind of nothing. Who did C before they did C++? It's less hands every year, but I'd say it's still a good third. So in C, well, if you go back far enough, you don't even have to say parameters, but you can still in C++ leave out the parameter names. Okay? There's this function called determine total taxes, and it takes int. And I tested this last week in a very up-to-date compiler, and it's like, yeah, I'm good, thanks. Okay, but you're not good, don't do that. Okay, that's not fair or right, and most of us never do that. But did you know that you can also in the definition if you're not using the parameter, which can totally happen. You know, it's some kind of virtual function that takes 3 parameters. You don't care about them. Also, APIs change over time. And the reason that you can, and the reason it was added, and I have this from the horse's mouth, is to suppress the warning about not using one of your parameters. So if you take 3 parameters, you give them all names, you don't use one of them, you get a warning. But if you don't give it a name, you don't get the warning. Yay. But even if you're someone who's like, oh yeah, we compile at a high warning level and we get 347 warnings, and if we ever get 348, we'll investigate. But there's a huge 347 on the whiteboard in the team room, and everyone knows as long as you get 347 warnings, you're golden. I wish I was making that up. But you can suppress the warning by hiding the name. But even if you don't care about suppressing the warning, once you hide the name, you make the function easier to call. Imagine I need to call determine total taxes, and these are prov rate, fed rate, and municipal rate. This is a Canadian slide deck. We have provincial rates, state rates for Americans in the room. And it says municipal rate, and where I live, there is no municipal rate. So now I'm like, oh no, I can't use this function because I don't know a municipal rate to pass. But if I see that it takes prov rate, fed rate, and then just an unnamed int, I know that means it doesn't use the third parameter, and I can pass 0 or -1 or 10,000 or whatever I feel like because it won't be used. I'll probably pass 0, that's kind of polite, but I get a reassurance as an API consumer that in this particular case, it's okay. It doesn't matter that you don't know what to pass for the third parameter. Nobody cares what you pass for the third parameter. Whereas when you gave it a name and ignored the warning, you missed an opportunity to give information to the caller. And it is a very big signal and one that I wish more people gave. This is the recommendation from me for how you declare these functions then. Okay? Do include variable names if you're going to use the parameter, and don't if you're not. Now I want to drift a little from nothing because I think there's some related things where you're making a seemingly arbitrary choice that communicates. And these are not so cut and dried about what the choice means. I just want you to start loading them into your head. When we first got truly smart pointers compared to the dumb smart pointers we had before, there was a great rush to say that there should be no more raw pointers. And that was never the actual rule, right? There should be no owning raw pointers. So if I meet a raw pointer in your code, is it an owning raw pointer, or are you a good person? Send emails takes an employee pointer. Without going and looking at the code for send emails, if you're the proud owner of an employee pointer and it's an owning pointer that you intend to delete, is send emails going to clean it up on you when it's done? I don't know. Could it come back null and you can't delete anymore? I don't know. This one, this is scarier. Send emails now is going to give me back a message pointer. I bet you it newed up that darn message, but maybe not. Maybe someone else did it. Who's managing messages lifetime? Is this my problem? And it's a very hard question to answer if you can't talk to the developers. Even going and reading the code for send emails isn't necessarily going to help you. So I try to talk to the developers by reading all the rest of the code. If the rest of the code is full of shared and unique pointers, these people know about smart pointers. And this is probably just a sort of observing pointer that I don't have to worry about the lifetime. If every class has constructors and destructors, and the constructors are newing things and the destructors are deleting things, and they've clearly shown their grasp of the rule of 3, so they have copy constructors, they have copy assignment operators, some of them have got move constructors and move assignment operators, so they're doing the rule of 5. That's the game they're playing in their code. They're doing new and delete themselves. And that raises the chances dramatically that message is an owning pointer that I'm supposed to clean up. Right? But if I go through their code, and I don't see any destructors, or I see one that closes a file, but I don't see any memory management, don't see any deletes, I'm not introducing delete into this code base, right? Message pointer is clearly, they've just given me an observer pointer in case I'm curious and want to look at it or log something, but its lifetime is being managed by someone else. I can only learn that from the other code. Well, or maybe by reading send emails, but I don't want to. And there are wrappers, right? You can find things, observer pointer. The guideline support library has an owner, which does nothing, but it just tags that this is an owning pointer as opposed to a non-owning one. But you really have to use the rest of the code to speak what the default is, and if it's not tagged, it must be owning, or if it's not tagged, it must be non-owning. What does it mean to take something by reference versus to take something by address? Back in the day, when we were trying to still do new and delete by hand, we tried to make this choice, which is arbitrary, carry meaning. And you may have worked in places like that too. If I pass it to you by reference, you can change it, but I still own it. If I pass it to you by address, you can delete it when you're done. It's yours. And I'm glad we don't do that anymore, but I still meet code that does that. And in some cases, that rule is not written down anywhere. Everybody knows it, except that everybody who knew it, has left in about 2005. And so we have to deduce it from the code that's left behind. It can be really kind of mind-twisting to come across a paradigm like that. It's not a rule, it's a foundational belief and behavior system, simply because it is not written down. When I was a young person, someone asked me if I felt pressure to go to university when I finished high school. Both of my parents have PhDs and were university professors. And I said to the person, did you feel pressure to wear clothes when you were a child? Like you can only feel pressure to do something if you have an option not to do it. And that's the level of rule I'm talking about with this star ampersand business that people do. It's not written down because it's like you have to wear clothes when you come to the office. That's not written down either, but everybody does it, I hope. We have lots of ways of doing things over and over. We have while. We have two kinds of for. How do you choose which kind of for to use? Some people default to the for they've been using for 30 years and only use arranged for in special cases. And some people default to arranged for and only use a traditional for in special cases. So if I see a non-ranged for loop, Is this like alert, alert, danger, Will Robinson? This is a strange loop. It's not touching them all. Maybe it's touching every other one. Maybe it sometimes backs up and does it again. Or are you just a person who likes using the old style loop, even if you are touching every element? So once again, the answer is not in this file, right? The answer is probably in your other files. What is the reason why you did it this way? And for that matter, why are you writing a loop? Scott's here this week, right? How long has Scott been saying no raw loops? We have a function for that. Now that we have lambdas, the last 7 years, we have no excuse. Like, oh, I don't like function pointers, they're so yucky. I agree. But we have algorithm. It's available to us. If your loop is finding all the rush orders, if your loop is updating the date on everybody's file, we have algorithms for that. Why aren't you using an algorithm? And then you may say to me, oh, because for my data, there's this weird edge case and such a thing doesn't work well. Okay. If I know you use algorithms, if I saw accumulate, which in my mind is an honorary member of algorithm, even though it's in numeric. If I saw accumulate, if I saw find, if I saw any of, I love any of and all of and none of. They're amazing. They do what they say. Right? I want to know if all of these are rush orders. You get back true or false. If I see those elsewhere, then this loop gets my attention, right? What is happening here? What is so unique and special that it's not a problem any other programmer has ever had before? I want to read this loop. But if you just apparently aren't aware that there's a standard library, then your loop doesn't carry that sense of drama and tension to me, right? Initializing. Here's another piece of nothing. I got 5 or 6 constructors in a class that's got 5 or 6 member variables, and I'm reading one of the constructors, and we all know the best place to initialize the member variables is before the braces, after the colon, and there's a member variable that's not there. So they're never A, B, C, D, E, but let's make them A, B, C, D, E, and E is not there. E is not initialized in this constructor's initialization clause. Why is that? Well, maybe there's a non-static member initializer. When you're initializing to a default value rather than a parameter to the constructor, then a non-static member initializer is a better place to do it because you do it once, and then as long as the other constructors don't mention it, that's the value it will get. That's actually better. That's a good thing. But that's not the only reason it's not there. You all know that. The other reason is maybe it's between the braces, which isn't always wrong, but is often wrong, right? So the answer to why might be because it was done by a Java programmer who's come into C++ and is putting all their initialization in the braces. But I like this one. Oh yeah, when we added E, I forgot to go to all the initializer clauses and initialize E. Or I forgot in some of the constructors. That's a good one. That's a fun one. It all boils down to this. Did you say nothing because you forgot, or did you say nothing because there was nothing to say? What can you do that everybody knows which game you're in? Now there's one contradiction, and since we're on initialization, I put it here. Here I want you to say nothing. This code puzzles me, and I see it a lot. And I go, but if you just said string S, you'd get quote, quote, right? You'd get an empty string. If you just said vector of employee department, semicolon, you'd get a 0-length vector of employees. Why are you doing this? Now, I'm not one of these people who feel sorry for the CPU. You know, like, oh, the poor little CPU had to, no. What are you doing to me? Okay? Do you not know that that's what you get? Because to be fair, if you say int I, it's not 0, right? So the person, especially again coming from another language, is like, C++ doesn't initialize things for you. You got to initialize your stuff. And that's a good lesson. And is that all that's happening here? Or did it used to initialize the string to like space or 27 X's or something, and then there was a business rule change and they just chopped it down to quote, quote, without thinking about the fact they could just take it away completely. So suddenly, this like a little innocuous line, I'm staring at for 10 minutes, and I'm reading all the rest of things, and what do we do with S after this, and is there something important in the changelog? Because I'm at the door to the pyramid, and I'm trying to understand how to get in, if I slide this rock this way. And the person probably didn't give any thought at all to writing this line of code, but they've stopped me in my tracks. And so here is actually the one place where I'm going to advocate for nothing. Is just say string S. Just say vector of employees department. I asked if you would use implicit. We are probably getting explicit at false, just like no except at false. Actually there to help people writing templated code. If you're trying to wrap something up and the thing you're wrapping has a constructor that is implicit, it would be good if your constructor was implicit, but if it has a constructor that's explicit, it'd be good if your constructor was explicit. That's a hard problem to solve, but if you get explicit at bool, then you can say wrapper's constructor is implicit depending on whether or not the wrapped item, T, is implicit or not. But I can now say explicit at false, and it's a way of saying implicit. In fact, I might use a macro for that. But we're not going to get const at false, I don't think so. We're not going to get non-virtual, we're not going to get by val. We got these compiler warning suppressor attributes, fall through, maybe unused. Anyone using them? Very small number of hands, all in the first 3 rows, I'm just saying, clearly where the keen people sit. Come early, get a seat at the front, use the new keywords. If you're not using them, don't tell me, but ask yourself, why not? I think it's because they don't do anything, right? They don't change your code. Why am I typing it? Nothing is different after I typed it. If all there is in the world is the compiler, nothing is different. But in my brain, when I have to read your code, something is different, right? And you're communicating with the future. And that's what I want you to do, communicate. When you write code, yeah, it works. Calculates the taxes, good for you. We get the revenue, I like that. But if you're also writing it as a communication device, you have to think about your message to that future reader. And I know we're not all altruistic, so remember that the future reader might be you. Or that nice junior developer who just started, who you like, and who you would like to take this project over for you when you move on to bigger and better things. Okay? It could also be your child. I have actually employed one of my children, both of my children. So show that future reader why you did this. Don't leave them that puzzle where they're trying to figure out how to get through the big stone door. Don't leave them going, what? I can't, huh? That's not nice. And even if you don't care about them at all, don't have them think you didn't know any better. I can't believe that Gregory wrote this code and doesn't even know that there's such a thing as const. Right? That's terrible. You don't want people thinking things like that about you. So you want to make sure that your code explains itself in that. And that means really focusing on what you did not say as well as what you said. What are you not choosing to do? What are you not using? This is C++. We have 5 ways to do everything. And if you find something there's only 3 ways to do, go to the committee, we'll add the missing ones. So you always had choices. Did I use a for loop, traditional or ranged for? Do I use a while? Do I call something from accumulate? Do I use go-tos and ifs? What does it mean that I made that choice? What am I trying to tell you? How can people understand your defaults and your behaviors from those choices? Not everything you want to express can only be expressed as nothing. Right? All the way back to returning at the bottom of voids and public in your structs. And there are times you just be verbose. But sometimes all you have is nothing. And so then the challenge is make that nothing carry information. and show in the rest of the code, in the context, show who you are. Show what you do. So that someone can say, if Kate didn't mark this no except, well, that's a bad choice because I could no except false. If Kate didn't mark this const, it's for a reason. It must change things. And I want you to be generous to future you, who deserves it, to your future reader. Give them everything they need because your nothingness is speaking volumes, and they will understand what you mean when you say nothing at all. Thank you. I have a small amount of time for questions at the mic.
So in the slide where there are two functions and both don't have a return statement.
Thimble and spiral? I can't
Yes.
believe you couldn't remember my function names.
And one of them actually reaches the end and one doesn't reach the end. The one that reaches the end, you suggest to explicitly provide the return statement on the left?
Right, after Robert minus minus,
Yes.
return.
Okay, thank you.
Yes.
Hi, on semi-related topic, one of the challenges I think that we're facing is that the language is progressing now at a far higher rate. New syntax, new idioms are occurring on an almost daily basis, depending on how many blogs you read.
It's a great time to be a developer.
Absolutely. But to the point of expressiveness,
Yes.
do you have any thoughts on how to deal with the fact that, say, now we have folds, which if you're a programmer that has not come across them look absolutely insane, but really express what you're trying to do rather than the alternatives?
I'll give you an example. The immediately evoked initializing lambda expression. Okay? Beautiful idiom for those who haven't met it before. You've got some variable that's complicated to initialize. You need a loop or a switch or something. And you want it to be const because once you've got it initialized, it never changes. And so you can write a lambda and say, whatever the type is, I never use auto here, whatever the type is, complicated variable equals lambda, and then at the end a pair of parentheses. So that invokes the lambda immediately. The problem is people who don't know the idiom don't necessarily see, especially if it's a 3 or 4 line lambda, they don't necessarily see those parentheses and they don't realize it's being invoked. And they're like, oh, they're setting up some lambda for something, whatever. And then they're like, no one ever calls this lambda, I don't understand. If everyone knows the idiom, it's fantastic. If they don't, you just made it confusing. I do not have an answer. It is the question. Yes. Over here?
So first of all, thanks for writing the talk that I'm supposed to be writing for the next 6 months to deliver to our devs. So I wanted to ask you about the slide that
I like dark chocolate.
Yeah. I wanted to ask you about the slide that I will plan to skip when I show this. And that was your talk about default initializers. It seems to be at odds with your statement
Absolutely.
that you write private right after you write class, or public right after you write struct.
I agree. I feel funny here. I may change over time. Today, I'm like, why are you telling me what I know? Yet, I want to return at the bottom of the void function. I want to say private and public in the structs. I want to express every default I can, except for some reason, not these. And I went on social media and asked other people to see if it was just me, and other people are like, no, I hate that, that's really confusing. I may change over time. Today, I'm like, don't tell me that.
So, yeah, there are two reasons why I disagree with that, and you can tell me why I'm wrong. First of all, what happens when someone comes along later and changes this to generic code, and instead of string, you now have T, and the default might be different because maybe you change string to string view or something like that, or string could be either string or string view. And the second one is that default initializers don't do what people think they do for built-in types.
For built-in types, absolutely. And I think this is what it comes from. People are busy doing as the ints do. So this is probably the least strongly held of all of my opinions. So I'm not going to rebut you when you argue with me because you might be right. Over here.
Hi, I have a comment and a question. So when you talk about optional returns,
Yes.
maybe this is a portability thing, but one thing that I use and really like is you can tell the compiler, like I think assume unreachable or something like that. And even better, you can have a macro that expands to that in production and like aborts in debug. And it's really great because it both.
Oh, that's the comment should never get here line?
Yeah. Well, it's not a comment. The compiler uses it and it produces better assembly, and you get the abort and debug. It's actually really nice and communicates and.
So
really
in the
fits in
case
well.
of Sprile, you would put it after the loop, saying we can't get out of this loop. If we
Yeah.
get out of this loop, something really bad has happened.
Yeah,
Yeah.
I'd use this macro. And I have a question. So one keyword you didn't talk about that I think is really interesting is final, because I've seen people before recommend, yeah, like don't use final on a class unless you have a reason. And what's funny is then I say to those people, okay, let's assume that final didn't exist and instead you had derivable. Would you be telling people the same thing? Always use derivable unless you had a reason? And then most people, if they're honest, stop and they're like, oh wait, like I probably wouldn't tell people to do that.
So this is the case. All our defaults are wrong, right? It is again, and there is something really powerful about doing the default versus not doing the default. And if the default was final and you had to say derivable, most things would just be final because you're like, well, I'm not writing it to be inherited from. Sure, that's cool, but that's why sometimes just the silent default, it doesn't show any thinking. As soon as you put a keyword in there, you're showing that you thought.
So do you use final on most of your classes?
I do not. But I probably should.
All right, thanks.
Hi.
Hey, Kate. Quick question about the int that you never named.
Yes, the unnamed parameter.
I'm wondering why is it there? Is it an interface you got from somewhere else?
Sometimes it's an API drift. Okay, there's a million lines of code. They're all calling this function, but there is no need for the third parameter anymore. But at some time when there were no refactoring tools, the decision was made to just leave the API alone. But very often it's a virtual function situation, right? So when I was writing Windows stuff, you get command handlers. They give you two things. There's like the control that was clicked and the place it was clicked or something. And usually I do not care where on the button you clicked, so I never look at that parameter. And that's fine. There's nothing wrong with that whatsoever. And in a lot of virtual hierarchies, you'll be getting information you don't need. So that's a sort of bad example because a human isn't typing code to call the event handler, but it happens in other contexts as well.
Thank you.
Hi.
Hi. In one of the talk, you told that if you don't use parameter, then don't pass the type. If you want to use the parameter, then only pass the type and
not pass the type. Give it a name.
Yeah, name and type.
Yeah.
So what about passing null? Let's say for the future use, I want to use some of the parameters of a method. So I want to pass it as a null instead of passing the type. So is that good?
You cannot really future-proof your API. I hear what you're saying, like let's add another parameter, and today people are going to pass null, and later they'll pass a pointer to something real. We live in a land of refactoring tools. If you want to add a parameter or take a parameter away today, you should do that. But there is a ton of code that's out there that is calling functions that were written in 2002, and no one's going to go in and change all the calling code not to pass the third parameter. So we'll just settle for telling you, I don't care what you pass. You can pass 0, -1, 1,000, doesn't matter. I'm not going to use it. And that's what this signals. So when the last parameter has no name, and I'm calling the function, I know that I can put anything, as long as it's integer, I can pass anything I want. It won't be used. It won't affect the runtime behavior. Okay?
Thank you.
I have 1 minute.
Okay, just since we're on this topic, I did have a comment on this one too. I think that whether you name it or not shouldn't reflect your implementation, but your interface. So it's helpful for reading code, and definitely encountered just this case within the past 2 weeks. But on the definition, if it doesn't, then I know it's something about how it's implemented, and so maybe in some cases, if I'm updating it, it's fine that I don't know what to pass in. But if any one in the virtual hierarchy, if any one of them cares, then I would like to know what I should put in case eventually someone else is going to care. So if it's in the interface, it's ignored. I'm expecting it never to be cared.
I suppose here's the thing. If your checking account update service charges method is virtual but calls the base and passes all its parameters up to the base and then does its own stuff, then it's using that third parameter because it's using it to pass it to the base, and so it should give it a name, right? But if it never does it at all because it's a complete override, then I think the information of actually checking accounts don't care, I don't know what state you live in, that carries information. And it won't break any code that chooses to pass the meaningful values.
Meaningful values, but if I put something, like it was being said that you could possibly not, so what is -1 a special value? It's a bad
Right,
thing,
you don't
but-
know, right? If you see -1, you think it's a signal, yes.
Yes. The other thing is about non-virtual. That's the scariest one for me, that we don't have something there, because nothing isn't the opposite even. It's whether someone in your entire hierarchy.
Up the stream, yes. Maybe I don't need to say it because it's inheriting from a virtual function. Yep, I agree.
So is there some reason why you said that you were expecting we won't get this someday?
I just don't think it's an easy problem to solve. Yeah, yeah, that's all. Unfortunately, I'm out of time, but I'm welcome to talk to everyone one-on-one, and thank you again for getting up and coming and seeing me.